So today we have IAM Policy Power Hour. And you might be asking yourself, what is a power hour? Well, we're going to pretend like we're going to the gym. Don't worry. The only thing I'm going to ask you to do right now is a little fist pump for policies. Okay? Yes, there we go. Awesome. So this is how we're going to spend the next hour. We're going to do a warm-up. I'm going to give you an overview of understanding identity and access management, so IAM policies. We'll do some balance training. We got security teams and builders and how they work together. We have some resistance training. We'll restrict access with permission guardrails. We'll do cross-account training, or cross-training. And we'll talk about cross-account and public access. We'll do agility training. This is all about getting your builders to set their own permissions and verify those permissions. We'll do some interval training to identify external and unused access. And then finally, we have a recovery. This is a new feature where we actually give you the policy to remove your unused actions. So we have a lot to cover. We're doing 5 demos, 5 live demos, hopefully as long as the internet's working. And we'll cover some new items as well. So I hope you all have a good time. All right, understanding IAM policies. So you probably heard it today multiple times, the shared security model. 2 parts, access controls in AWS. One is my job. My sole job is to provide robust access controls so you get to define who can access what, under what conditions. My other job, our other job, is that for every request to AWS, your access controls are enforced. So that means that when somebody accesses AWS in your AWS environment, there is either an allowed or denied, and it is only allowed when you say so. And then finally, someplace where we've been investing and we've provided a lot of launches is the guidance, helping you all get to the right permissions for your workloads. And so what is your job? Your job is to create and maintain and refine your access controls based on your business needs. And we talk about setting those access controls, verifying them, and refining them further. So you'll see a lot of that today. All right, so I'm going to hit it off hard with a demo. And I'm going to use Secrets Manager, and I'm just going to pop around and show you what I got. So we have some central security secrets. I'm going to be in a dev account. I have some secrets tagged Project Pickles. For those of you who have not joined me before or have not watched a YouTube, Pickles is my horse. You will see him many times today. Turns out it's a lot easier to put a picture of your own personal horse than some other ones. So we're going to do that. All right, here we go. This is just to get things started. So I have an org. I'm using Identity Center to pop around. I am going to head into the org management account. And the reason I'm going to do this is I just want to show you an SCP, a service control policy that I have going on. And I'm jumping right in just to give you a sense of some access allowed and access denied. Central secrets, and you can see that I've denied access to security no. This means you can't have access, except for the central security role. All right, so that's the policy that I have. You can see that it's on my workload accounts. Now I'm going to pop into the dev. I'm going to pop into my Secrets Manager demo. I've given myself access to review my IAM permissions just so you can see them. I want you to be able to see them. Let's go to roles here. And where's my Secrets Manager demo? Let me see. Oh, here we go. And you can see I don't have a lot of permissions, but I do have enough to read my own policies, which I'm just going to expand here. And so I should have access to read secrets tagged Project Pickles and to list all secrets. Okay, now I'm going to head over to Secrets Manager. And as I go to Secrets Manager, I need to make sure I have the right region, which I do. I'm going to click on things, and I want you to, in your head, guess if I'm going to get an allowed or denied. We'll play a little bit a game here. So, yes or no? The answer should be no. Why? Because even though this is actually tagged, if you could see the whole thing, Project Pickles, that SCP kicked in, and I hit a guardrail. I'm a developer, had a little bit broad access, I hit a guardrail. But nighttime treats, yep, I can see it. Why? Because it's Project Pickles. Human treat. Should Pickles have access to human treats? No. Why? Because it wasn't tagged Project Pickles. So you can just get a sense of where a dev might pop into, hit some of those guardrails, where they might be allowed fine-grained access and where they might not be. And how was all of that happening? Well, it was all happening every single time I hit one of those secrets. A request was made to AWS. Secrets Manager made a request based off my information. I was the Secrets Manager demo role. I was trying to access the Secrets Manager service. I had a session. I had authed. I was coming in from a source IP. I had some tags on me. So that's the context. That's what the service passes. Then there are the policies. And together, only if it's allowed will access be granted. And a deny will always win. And so every time you're like, oh, it's denied, think about the context, think about the policies, and only if there's an allow statement will access be granted. And how do you specify those controls? Well, we like to talk about the PARC model: principle, action, resource, condition. So principle is what principle is performing the action. If you're a role, you have a policy attached to a role, you don't need to specify this. We know the principle. You want to specify the action. There are thousands of actions in AWS. This helps you get really fine-grained to make sure you can only do what you need to do. What action on which resource, so that's the resource element of the policy. And then finally, conditions. Conditions in your head translate to, but only if this condition is met will access be allowed. And I will use that but only if many times. But only if this request is made first via Lambda. That's what the last condition is. Okay, so where do you put this PARC? Where do you put all the PARCs? You put them in policies. We have multiple different types of policies to allow you to define access across your organization. So the top ones are all about restricting access. These are your service control policies. You define them at the org and OU level. SCPs do not grant access. By default, there is a star policy, SCP, on the organization. That policy does not grant full access to everybody in your org. All it says is, hey, go listen to the specific permissions in the account, which start with deny by default. So only allows kick in. Next, you have your permission boundaries. Permission boundaries also do not grant access. They only restrict it further. You want to use permission boundaries to say, hey, dev, you can create roles, name this way, but only if they have this permission boundary. That means that if they create a role with full admin access, they can hit up against that permission boundary, and that access won't be granted. It allows you to define the maximum permission. You have your VPC endpoint policies. That's specifying who is allowed to access the VPC endpoint. Okay, at that time, if you've only played with service control policies, permission boundaries, and VPC endpoints, no access. You got nothing. You got to go grant access, and that happens in two places. In identity-based policy, these are going to be attached to your roles. They let you define what actions that role can take on which resources and under which conditions. Or the resource policy. Buckets have resource policies. Secrets have resource policies. DynamoDB tables now have resource-based policies. And you get to say who can access this resource. So this is how the enforcement happens. We talk about that context. I introed it before. You have get secret. You have the specific secret. All the tags. The principal may have tags. All of the policies, SCPs, permission boundaries, identity policies, resource-based policies. One answer: allowed or denied. There's no middle zone, allowed or denied. All right, so when I'm popping around AWS, this is essentially how I think about access and how it flows in my brain. So I want to share it, and then we're going to go through some examples. So you have Pickles the horse, and first the VPC endpoint policy has to allow through. The service control policy has to allow through. The permission boundary has to allow. At this point, you go through those three buckets, Pickles has zero access. Nothing. So the ones in blue are restrictive. Then you go to the green policies. This is where you want to allow. Now, if you are in the same account, Pickles can have access to the secrets in the identity policy or in the resource-based policy. Why? because the trust is at the account level, and the resource is in the account, and Pickles is in the account. So one or other of those policies can say, yep, Pickles can have secrets. The minute you go cross-account, account A and account B, the identity policy must grant access, and the resource policy must grant access. And I've said this many times, but I had a customer tell me many years ago, and it's still in my brain, for cross-account access, both, if you have think of a hotel room with two shared, hotel rooms, some people get, both of those doors have to open for access to flow through. All right, let's take a look at an example. So I have Pickles. He has a role policy that says allow Pickles access to secrets manager. Bridget, who is, Pickles is in the barn org. Bridget is in Amazon. Yes, I work for Amazon. All right, and so Bridget, have a role policy that says allow me to get secrets as long as it's in the barn org. I can only get secrets from the barn. Okay. The resource policy says allow Bridget and Pickles access, so that's all great. But there's an SCP that says deny secrets manager on the barn org only. So if you see this, Pickles busts at that service control policy, right? That restricts access, a deny kicks in. Even though he has access all the way down the line, he will not be able to access those secrets. Now, Bridget, on the other hand, that SCP does not apply to her because she's in Amazon, and that SCP is only applied to the barn org, which means it only applies to the principals in the barn. It does not apply to principals at Amazon. So Bridget has green lights all the way through, and she gets access. All right, let's change it up a little bit. Same thing, Pickles has access from a role policy. Bridget has access from a role policy. The resource policy has changed, and it has now said only allow Bridget and Pickles access, but only if, we have a condition, the principals are in the barn org. I don't live at a barn. I don't work at a barn. I work at Amazon. So, okay, I'm going to bust there. And then the org barn has changed from a deny to an allow. And so you can see Pickles now, VPC endpoint, service control policy now lets him through. Both the identity policy and the resource policy say yes. One or the other would work in this scenario. And then Bridget, on the other hand, she doesn't have a service control policy, but both the identity policy and the resource policy need to be true. And this is not the case because Bridget is not in the barn. So she busts on that access deny. Okay, so now that we have done our warm-up, does everybody feel warmed up when it comes to policies? Okay, great. Let's talk about balance training. Security teams and builders. This is where the beauty happens. So, central security team, your job is to establish the perimeter, restrict critical access, all those scary things you don't want to change, you got to put guardrails on them. You set the security standards. This is what we need for you to provision resources. You provide tools to set permissions, and you identify broad access. Builders, you got to work with your central security team. You got to make sure data stays inside the organization. You want everything to adhere to the guardrails, Policies must meet the security standards. Please apply fine-grained permission, especially for your workloads, and remediate broad access, working with your central security team. And this is a pattern we encourage, We encourage central security teams to establish that data perimeter. There's a ton of content about establishing a data perimeter on your AWS environment. Please go look at it. I'm going to do one of the use cases today. You establish those guardrails, and then developers, you can allow them to kind of start a little bit broader, play, explore, especially in those development environments. And then as they work their way up to production, they can set the fine grain, they can verify it works, they can refine it further, and so on and so on. And this is how it works. I actually had a customer the other day tell me, oh, Bridget, that's okay because they're just going to bump up against our guardrails. And I was like, that's amazing that you have such great guardrails so that your devs can bump up against them when they're not kind of doing the right thing. All right, so that's how it works. So we're going to explore both of these personas today. So we're going to restrict access with permission guardrails. So your task is, this is Pickles, there you go. He likes green things too. This is bubbly water. It's not an alcoholic drink. So restrict modifying common security roles except for the security team. You're going to use SCP. So you're going to say, everybody in my organization, nobody can delete the common security roles. And this is what that policy looks like. You'll do a deny, all the roles. Nobody can delete Pickles -- because he's so critical to the organization. Central -- except that central security team. You saw this policy apply to the secrets earlier, so I'm not going to demo it. Data perimeters. This is a great term. So to establish a data perimeter, this is the way we think about it. Ensure that your trusted identities are accessing your trusted resources from expected networks. So that's 3 perimeters about identity, resources, and expected networks. And you can use policies to establish them all. So when we think about the identity perimeter, right, you're thinking about only trusted identities. So where do you need to put that restriction? You need to put it on your resources and on your networks. So you're going to put that in resource-based policies where there's direct resource access and your VPC endpoint. And you're going to say, hey, anybody who's coming here has to be part of Principal Org ID. For your resource perimeter, you're talking all about trusted resources. And you're saying you're putting that restriction on the identities and on the network. And you're going to use resource org ID. Hey, if you're going to touch a resource, it's going to be in my org. And then finally, you have your network perimeter. And you're going to talk about always expected networks. Access is coming through expected networks. So you got to go hit up your identities and your resources and say, always expected networks. For identities, you'll use a service control policy. And for resources, you'll use the resource-based policies. All right, so I'm going to demo one of these today. So your task is to make sure my identities can only access trusted resources, right? And I'm going to demo it, and I'm going to give you a little bit of a setup. I have a bucket. It's outside my organization. It has too broad of access. It's allowed access to a bunch of different stuff, okay? Pickles has access to the bucket. He's actually in the same account of that bucket. Then I have an ice cream dev. I don't know where I got this from, but there's a developer working on an ice cream app, and they're inside my org, okay? I'm going to demo that both Pickles can access it because it's in his account, as well as ice cream dev. Then I'm going to apply this SCP, which I'll show you here in a second. And hopefully, if my demo works, then the ice cream developer should not be allowed access. They should not be allowed to copy data from the organization into Pickles' bucket. I don't think Pickles likes ice cream, so this works out. All right, so we're going to put an SCP that says deny all S3 actions as long as the resource org ID is not equal to this org. Right? So this means the deny only kicks in when the developer is trying to access a resource outside of their organization. So string is not equal to this org. All right, here we go, demo time. All right. So I'm going to do this from the CLI. I am going to show you commands. Here we go. So this is Pickles' grain bucket. Pickles has access. It has pretty broad settings, unfortunately. And you can see that it's there. This is basically just to show you it's there. The ice cream developer also currently has access. We don't want this anymore. This is allowing the ice cream developer to access Pickles' stuff. They might copy ice cream recipes into Pickles' bucket. That's not good. So what we're going to do is we're going to head over to the org. I have not attached the service control policy that restricts it yet. I'm going to show you the policy. Here it is, just what I said it was. And I'm going to attach it. And I don't want anybody copying data outside my org. Oops, dismiss that. All right. So you can see at this time, Pickles is still going to have access. This is intended. Pickles owns this bucket. It's outside the org. Pickles can do whatever he wants with his bucket. The developer, on the other hand, should not have access. access denied. I did not change the dev's permissions. I didn't change the bucket's permissions. I put an SCP. I restricted access. If you want to roll this out, you can do it account by account, OU by OU, but it's probably a very good thing to do, so please take that away with you. All right, moving on to cross-account and public access. I just demoed a little bit of cross-account access, but let's talk about it at a deeper level. So we have the pickles pasture, and we have the treat account. You can see there's some carrots, there's some apples, good horse things. There's also some chocolate, not some good horse things. There are two ways to access resources within an account across different accounts. One is to assume a role into that account, so Pickles could assume the treat role and get access to what he needs in the treat account. Or those resources can have resource-based policies on them that grant direct cross-account access to identities. And so you can see in the treat account, the carrots and the apples, I'll go into the apples, the apples has a resource-based policy on it that says, allow horses in my barn access to this. This could be a bucket, this could be a DynamoDB table, right? And then if Pickles assumes the Pickles pasture, he will get access because let's assume these are both in the same organization. So that's how cross-account access happens. You want to be verifying your resource-based policies and making sure they are granting very specific access to accounts that you trust. So when you're granting it, you want to think about what can I do just if I'm looking at any resource-based policy, whether it be on a DynamoDB table, an S3 bucket, a secret, a queue, a topic. So in the bottom statement, it says, allow John access to this table. Then I also added a deny statement. This is a statement you can copy and paste to all of your resource-based policies that say, deny Dynamo access, all access, if the principal is not in my org, right? So this deny will kick in if a principal from outside your org tries to request, and you want it to kick in if Pickles has, gone to a different org. All right, so that's a little bit about cross-account access. Please inspect your resource-based policies. We'll talk about how you can identify external access in a second with Access Analyzer, but just needed everyone to know this. Also, if you're doing resource sharing, this is more common. You're using more accounts. People are sharing common resources. Please go look at RAM. This is Resource Access Manager. The beauty of RAM, they cover 58 resource types, more on the way. But you can create a resource centrally, you can share it with accounts in your organization, and the coolest part is when it's shared with accounts in your organization, it actually shows up in their list calls. So you can see it, you can work with it, you don't have to discover it on your own. It has that discoverability aspect for it. This is really good for networking resource types, a lot of data analytics resource types, and most recently, this was a top ask from customers, we added Systems Manager, so you can essentially create your parameters once, share them multiple places, and it works pretty well. All right, another aspect of cross-account access and those resource-based policies is confused deputy. So I like to think of confused deputy is when you're granting access and that person who's accessing the resource, so the apples in this case, might be confused where access is coming from. This is going to, when you look at a resource-based policy and you see that you've granted access to an AWS service, you want to be like, do I have confused deputy protections? That's the question that you should ask in your head. So if I have a policy that just says, allow horses to eat my apples, well, it could be Pickles, or it could be another random horse named Milo, some from another barn, right? And so you want to make sure that you put in the right protections. And the way to do that, so you see this says allow SNS to send messages to this topic, but only if the source org ID is from my org, right? So if horses were an SNS service, you can kind of take that example and do it. But you want to make sure that if you're granting access to an AWS service, that it is actually coming from within your organization or an account that you trust. You can also use source account. All right, so we have done our warm-up. We've done some balance training. We've done some resistance training. We've done some demos. Now we're getting to the fun stuff. And this is all about agility, giving your devs the ability to create their own policies to verify that they meet security standards. So when it comes to creating policies, kind of 3 ways to do it. Well, three tools that you can use. AWS managed policies. These are a great way to get started. They are for common AWS use cases. They apply to all customers. This means that they are broad. You should not live in AWS managed policy land unless you want to live in broad permission land. But they're a great way to get started. Then, once you have your permissions, you're working through your workloads, you can use policy generation. So you can run your Lambda function, run whatever workload. It uses a role. Okay, great. You do policy generation. You say, hey, look at the last week. I was really developing hard there, and it'll generate a policy for you. It'll give you all of the actions. So we look at your CloudTrail. We map all of those events to individual IAM actions. We give you all the actions, and we actually also give you templates of where to put your resources. So if you want to add specific resources, we do that too. All right, you finally have your policy, whether you've generated it, written it in your sleep, written it by hand, did some DIY policy creation, and then you can validate. And so validate is AWS prescribed checks. We have security warnings, we have general warnings, errors, and suggestions. And you just want to make sure that your policy is functional, adheres to all the standards, and goes from there. But we have more, don't worry. So this is all AWS prescribed. So you want to get to helping builders verify their IAM policies. And so at re:Invent, we launched 3 new APIs to help you do this. All of these APIs use automated reasoning, which is math-based logic to assert that certain statements are true about IAM permissions. And we are seeing customers put these in their IAM policy tooling in their CI/CD pipeline. So that's how you want to think about these APIs. You actually don't experience them a lot in the console. You'll experience them way more when you bring policy development closer to that the builder's building. All right, the 3 checks. Let's go through them. First is check no new access. This is going to be really helpful when you are saying, all right, we got a bunch of broad permissions. We want to scope it down. I'm going to get the devs submitting new policies. Well, you can run a check. Existing policy, new policy, pass it in, and it will return pass if the new policy is equal or less permission, so not introducing new access, and it will fail if that policy has introduced new access. Pretty powerful when you're thinking about scoping down permissions. Second one is access not granted. Now, there's a little bit of a fake out because this is not really new. We launched this at re:Invent, but there is a new part to it. So you can say, here's my policy, and I want to make sure that the policy does not grant access to delete a DynamoDB table. And the new part is on this specific table. So if you've got some crown jewels that you want to make sure nobody has access to delete, you can run a check that says, make sure this policy does not allow you to delete my crown jewels. You pass in the policy, you pass in what you care about. We give you a pass or a fail. Pass if it does not grant access, fail if it does grant access. What we are also introducing is check no public access. With more and more resource-based policies, if you author it in a way that's too broad, you can actually grant public access to your resources. And we don't like that. Nobody likes public access. And so it has some use cases, but in my world, we don't like it. And so you can take a resource-based policy, tell us the resource type, and it will tell you if the policy is public or not. So we're going to demo all of these today. So your first task with Pickles is to verify the updated policy does not introduce any new access. This is an identity policy. You're going to use check no new access. So we're going to pass in simple. Now, I am using very simple policies, and the reason I'm doing that is because of slide constraints. I would love to be up here and show you a ton of complexity because you can have policies that are like allow, deny, condition, allow, deny. Like you can throw in all the things that you've accumulated over the years into your existing policy, and then maybe you're gonna even simplify it with a new policy. And you pass both of these in, and it will tell you if the new one grants new access or not. All right, so let's get going here. I'm going to do a lot of flipping back and forth with that demo. All right, so I have that DynamoDB policy. I called it existing. And then I have this critical access, which is just a little bit more access. So what am I going to do? I am going to call check no new access. I think I can do it so you can see, hopefully. Okay, it's going to run, but I call access analyzer check no new access. And I passed in the existing policy and the critical access policy, and it failed. It said, you know what, in this statement, this is not great. You granted more access. And it gives you a hint as to where it is. All right, so that's checking no new access. Then your next rep, remember we're doing reps, policy reps, is to verify that the policy does not grant access to delete the pickles DynamoDB table, because nobody wants to delete pickles. Okay, so once again, you have a policy. This policy can be long. It can grant access to S3 and IAM and SQS and name any of your favorite services. And all you're going to do is an input is tell it what you care about. You care about the actions. You care about this resource. Let's see what it gives us. All right, so I'm going to show you those policies. I have the critical access policy. Like I said, I could copy and paste a bunch of stuff in here. And I'm just going to check that access not granted. Here we go. And so you can see what I did is I put in the DynamoDB delete table action, comma, resources. And so that's saying, hey, this pair of delete table on this resource is scary. That's critical. I don't want. And once you can see that I failed on the statement, this is not great. So if I was somebody looking at this policy, I'd go here and be like, whoa, this is not great. I need to workshop that a little bit. Alrighty, we're on a journey here. So now our next rep is to make sure that policies don't grant public access. So these are going to be your resource-based policies. I do want you to know that I'm talking a lot about Dynamo. This year, Dynamo did launch resource-based policies for direct cross-account access. BPA on by default. BPA means block public access. So you shouldn't actually be allowed to attach these policies. And we also launched with Access Analyzer external access findings. So if you're sharing your DynamoDB table externally, it'll generate a finding for you. So I just wanted to call that out. But we're going to play around with some policies and the check. I'm going to do S3, and I'm going to do Dynamo, and I'm going to tell you why in a second. So I'll show you what they are. And I'm also going to make them pass this time so you can see that the APIs actually do work. All right, so DynamoDB, I have broad here, and you can see I'm using source IP and source VPC conditions. First statement, pretty darn secure. Second statement, not so much. That source IP a little broad, don't you think? Okay, so what we should do is check public access, and I'm doing broad. I'm going to just do this, oops, so you all can see. And it failed. And it says public access granted with the following statement, broad access, right? So it tells you, and once again, this policy could be really long, it could be pretty complex, and it will tell you. All right, now I have a better, I'm going to call it better. I kept the first statement, and I updated this, and I made my source IP a little bit more specific on some delete put items. All right, so let me get the command for that. Try to get all the commands ready so you guys didn't see me type a bunch of random stuff. And you can see that pass. It is not granting public access. Good. That makes me feel better about attaching this policy. All right. Next one, I'm going to look at S3. So we got S3 pickles broad. This is allowing AWS star, S3 star on this bucket. And it basically says when the principal tag developer type equals horse. Right? That's broad. That can come from any account, any VPC endpoint. That can come from anywhere. Like you in the audience could put a developer type tag on your role and call it horse, and you got access. So let's hope that our API tells us that. Fail once again because it granted too much access. And I don't think I named my statement correctly. And then I'm going to make that policy better. I am going to actually say developer type horse as long as the principal is in my organization. So let's give that a spin as well. And it passed. So we did a good job. We scoped down our permissions so it wasn't super public. All right, so we've done a lot. And I want to talk about these checks because the command line, fine, you can use it like I just demoed. Where these checks and these APIs really have power is going to be in your developer tooling. And so we have AWS CloudFormation Policy Validator. This will run the actual IAM Policy Validator as well as the ability to add custom checks. There is, I'll also talk about, there's a plugin for AWS Toolkit on Visual Studio that's new in the last month or so. And then we have check no new access, and this is a bunch of reference policies. So if you don't know where to get started, you're like, what should I be checking for? What should I be looking at my policies for? We've come up with a bunch of reference policies that you can pass in for checking no new access. All right, so now we've enabled developers to be agile, but you are still a central security team member, and you want to make sure you identify external and unused access. So anytime somebody had applied a policy, might be a little broad, you want to know what's up. All right, so with Access Analyzer at the organization level, you can go, we have 2 finding types. If you turn them on, one or the other, you will get a dashboard depending on which one you turned on. And so it helps you understand your security posture when it comes to permissions across your entire organization. It can tell you how many public findings you have, how many external access findings you have, how many accounts have unused roles. I know you all know there's that one team that doesn't clean up their unused stuff. I have them in my org. You probably have them in your org. I just saw somebody smirk, so that means they might be the worst offender. And so this is a place to get a sense of where you should go spend your time and energy. Let me talk about these 2 types of findings a little bit more. So you enable your analyzer. First, we have external access. These are going to be your public and external access findings. We cover 15 resource types. We like to focus on the data resource types. And we generate findings for public resources and cross-account. Cross-account being outside of your organization. If you share with somebody within your org, that's in the zone of trust. We don't generate findings on that, but you can outside your organization. We integrate with Security Hub and EventBridge so you can pipe those findings to your engineers. External access is available at no cost. So if you do one thing today, you can go turn this on for an org or an account free of charge. Go turn it on. Like, go look and make sure you don't have any public buckets or you're sharing things beyond your organization. Then you have unused access. And if you turn this on, it will start generating findings for unused access keys. These are long-term creds. These are things you don't want lying around, especially if they have broad permission. Unused IAM user passwords, unused roles, and unused services and actions. These are a paid-for offering, so just letting you know. Sometimes people have said they want to turn it on in an account first and then bubble it up to the org, so I'm just giving you a heads up. If you do anything, you can turn it on, get your findings for unused access keys, and turn it off. But please go remove those unused access keys. All right, so we're going to go and inspect, and I'm going to do 2 demos at one time. I have it on for my org analyzer. I'm going to go pop around and show you some broad table permission, DynamoDB table permissions that I got going on, and I'm also going to show you some unused access. So we're going to do this one, and we're going to do the unused access one together. So much fun. All right. I'm going to head over to my security tooling. This is where I have my org analyzer enabled. I go over to IAM. I have turned on both finding types, both analyzer types. The one thing I will also say about unused access is you get to determine what is unused for you. So when you enable it, you can say 90 days, 120 days, 300 days, whatever unused means to you, you get to specify. I'm going to go over to Access Analyzer. And look at me, I have no public resources. This is good. I have some shared outside of my organization. So this is all about my external access findings. A lot of roles there. There should be a DynamoDB table in there, hopefully one. And then unused access findings, you can kind of get a sense. And it looks like I have a lot of unused roles, probably from experiments I have been running. I have some unused access keys. That's not great. And I can kind of look at the status. There's some resolved, so I've been doing some homework, but not too much. And I can go find the worst offender. Looks like my prod account is not doing a good job of cleaning up unused access, so I can go bother those engineers to clean it up. I'm going to show you a little bit more specifics here. One of my favorite things to do is resource type, and then we'll do DynamoDB tables. And you can see I have Pickles has some external access sharing it with this account, as well as Aperol Spritz DynamoDB table sharing it with that account as well. And so what I would want to do is pop down into those accounts and make sure those are trusted entities. They are. One is my personal account for playing around with pickle stuff, and the other one is somebody on my team's account that I wanted to share an Aperol Spritz with. So there we go. Unused access, we can pop over, and you can see I have a lot of unused roles. Woof, too many unused roles. I can kind of check out unused permissions as well. I have some service roles. I'm interested in just doing, let's do resource contains. Let's see if Pickles has anything that I need to yell. Oh, I do. So I want you to remember this. So this is up at the org level. I'm a central security person, and I've seen that Pickles has a role that's unused. Not cool, Pickles. Not cool. So what are we going to do about that? Well, we're going to remove unused access. And you're like, Bridget, this is recovery. Removing unused access sounds hard. It sounds scary. Well, remember all those unused findings we found, Pickles? Well, we have a present for you today. We talked about it earlier today, but I'm going to show you it live, demo working. And we do policy recommendations off it. So you can go to the finding. You'll want to do this within the account because you're going to be modifying the policy within the member account. And it will recommend your policies. So it'll say, like, this role has 2 policies attached. This was the old policy. This is the new policy we recommend with the unused access removed. And it will give you some steps to go and do that. So this is making life a lot easier to go and remove that unused access. I have favorite parts about this feature, and you kind of have this wow moment. I actually demoed this morning, and I actually was like, whoa, wow, that's so cool. And so when we are generating these policy recommendations for you, we take the existing policy attached to it. So if you had specified resources for some of your actions, if you had conditions in there, then we actually take that. We recommend replacement policies. So we say, take this policy, maybe create a new one because there's going to be multiple entities attached to it or whatnot. And here's a new policy with actions removed. It may have kind of expanded some of the actions on star, so it could remove some of them. It keeps the resources and conditions previously provided, and you get step-by-step instructions on how to do this. And then you're going to go remove the access, update the policy, and because we continuously monitor, we'll see that a policy has been updated, we'll reevaluate the finding, and if you're a wonderful developer, your finding will be resolved. Isn't that so fun? Should we demo this live and make sure it works? This is actually one of my favorite features. If you use it in the console, this is API. You can obviously generate policies via API. But use it in the console. It gives you existing policy and recommended policy. And you'll get to see both. So I'm going to show that as well. All right. Woo, here we go. Demo this live. I'm going to pop down into my dev. I'm going to go in as admin. Didn't have time to create that role. I'm going to hit over IAM. So basically the premise is I had a Lambda function. It called a bunch of things. It had a role. I'm going to show you that. That was the pickles thing. I have an analyzer turned on for this account, and this is so I can work on this account, get those findings, remediate those findings. I should be removing 25 roles, 11 access keys, and 6 permissions. And yes, I realize that sounded like a holiday song, but let's do the unused access here first. All right, so here we have, and I was talking about the pickles role, so we're going to go into there. This is the finding. It's unused permissions. And you can see the role, which I'll get to in a second. And it has these unused permissions. It says one of your CloudWatch logs is not used, and Secrets Manager is not used at all. Here's the existing permission that's attached, the existing permission policy. They're going to give you a name. You can obviously name it whatever you want. So this is pretty cool. I'm going to preview this policy. And you can see I had a bunch of actions here. And then, the new policy does not have Secrets Manager in there at all. And I'm going to show you this one as well, and then I'll go actually remediate. You can see here we have create log group, and we have create log stream and put log events. Well, these are the only 2 that were actually used, and it keeps the resource in there. All right. We're going to remediate some stuff. Here we go. I'm going to open the role thing. I'm going to go here. I'm going to copy this policy. Open this one. All right. I'm going to do a full copy paste. I'm just going to go for it. Just let her go. No Secrets Manager. That's good because that was the thing I saved. Okay. And then I'm going to go to this one. I'm going to go back to the finding. I'm going to go to the next policy. I'm also going to copy the whole thing. Let's go here. I'm going to edit the policy. Same thing, full on. Going to trust the recommendation. I'll click next. I'm going to click save changes. My Lambda will continue to run because it wasn't using those actions anyway. And eventually, I'm going to hit this refresh button, and I want everyone to look at, so let's go back to here. I'm actually just going to do resource contains pickles. All right, the finding is still active. So after I talk for about a few seconds, we'll go back, maybe minutes, maybe this is a minute. My dev's probably yelling at me right now. We'll go back and see if it was resolved. That clapping's not for me, but don't worry, we are almost there. We are almost through with your workout. And we've done a lot today. We've restricted at the org level. We've checked for a bunch of access that developers have. So these are the things that I want you to take back with you. First of all, if you are a central security team, please go establish guardrails. There's a lot of guardrails to establish. Data perimeter is one, making sure that your developers cannot write data outside the organization. That's the one I demoed. You also want to think about guardrails. What are your critical resources? What are your central security team IAM roles, the common things you don't want deleted? Maybe what are some critical resources that if it was deleted or removed was a really bad day? Maybe you don't want people modifying networking controls. Think about these guardrails and apply them at the organization level using service control policies. Turn on IAM Access Analyzer, external access findings. You'll get a list of your buckets, your secrets, your DynamoDB tables, public access and or external access. If it's external access that you intend, you can archive it. If it's not what you intend, please go remediate it. Go turn on IAM Access Analyzer unused permissions and inspect unused access keys. That is the place to start. Access keys are long-term credentials. You don't want those floating around. And if they haven't been used, you do not need them. They do not bring you joy. Get rid of them. Okay. 3 more for you. You're probably wondering why Pickles doesn't brush his teeth. I'm just kidding. He has really good dental hygiene. Anyway, as you're doing resource-based policies and you're creating direct cross-account access, especially for AWS services, to write to some of your resources, make sure you put on confused deputy controls. These would be that source account ID or source org ID. Make sure it's coming from your organization. Automate permission reviews with your developers, CI/CD pipelines, tooling. Heck, you can even just build a tool that checks it after the fact, but give developers that information of where, one, they're going to hit guardrails, or two, they're granting access they probably shouldn't be granting most of the time. And then remediate unused access findings. That's what we just did. I'm going to go show it. And finally, I have some places for you to go. These are my top 2 favorite IAM resources. I love thinking about access control and permissions. The first is the service authorization reference. One of the best IAM documentation pages out there. This will give you all of the services. I got a fist pump for this page. This is so exciting. I've never gotten a fist pump for a documentation page before. This is so great. This tells you all the actions, all the resources, all the conditions. And if you fist pump this page, please come talk to me afterwards. All right. And then I gave a presentation in 2018. For many years, I tried to make a better presentation, and everyone kept telling me this was the best. So I'm just leaning into it. This presentation goes through many examples of service control policies. If you're curious about permission boundaries, it goes into a lot of examples. It also goes into examples about condition keys. So a lot of people have found that presentation very, very useful. So should we see if my finding is resolved? Yet? I'm going to go with yet. I'm not even going to look first. Oh, you want to know why it went away? Look at that, because I had a filter on active. But the finding is resolved because I removed the unused access. So that's pretty great. We did our job, right? Thank you, everybody, for coming. I'm glad you're as passionate about IAM policies as I am. Have a wonderful Reinforce. I will be out there for people to chat.